Hello, good morning and thank you for joining us for this Dassault's latest webinar with Car Design News. My name is Owen Reedy and I'm the editor of CDN. As you know, this webinar will focus on new ways to design with CATIA for creative designers using Marc Boulangé's Silverbull concept bike case study. Over the next half an hour or so, we'll be joined by Dassault's CATIA brand, Xavier Meltonia and Pierre Marot, as together they showcase this innovative approach and explain how the software will liberate and boost the designer's creativity. Together, Xavier and Pierre bring a wealth of experience of R&D, software development, conceptual design, Class A and mechanical surfacing modelling, and their knowledge of design solutions to address industrial design challenges has been gained from a broad-based background in both the industrial and car design environments. Before we start, I'd like to invite all of you attending this webinar to drop some questions as you listen to this fascinating topic, which Xavier and Pierre will then be pleased to answer in the question and answer session that will follow immediately after their presentation. You can ask these questions by typing them into the box on the bottom right-hand side of your screen. If you do experience any technical issues during the session, please type a detailed message reporting the problem into the same box at the bottom of the screen, and our team here will do their very best to resolve them. We hope that you'll find this webinar stimulating and informative. It's now time to hand over to Xavier and Pierre, as they will now begin their presentation. Over to you, Xavier.
Thank you, Owen. So thank you for joining this webinar, where we will present a 3D experience solution called CATIA for creative designers, a software solution that was used to make the Silverbull project, the Silverbull motorbike by Marc Boulangé. So before to deep dive into a presentation of the software, let's see what are the four key challenges that we want to address with this 3D experience solution. First of all, our first goal was to support the complete creative workflow, from the inspiration through social innovation media to the creative workflow from ideation, concept modeling, refinement, up to Class A surfacing and reverse engineering, to design validation with physical and virtual prototype. And we want to give the ability to the design studios to cover this complete workflow in a unified industrial workflow solution. The second thing that we want to address with CATIA for creative designers is to bring back 3D accessible by the creative designers, to allow the styling and creative people to be able to express their creativity directly in 3D, like sculptors. Until now, 3D modeling for designers were way too complex through NURBS or Bezier surface modeling capabilities. And then with CATIA for creative designers, you will discover a new way to do creativity by doing 3D sketching, but also virtual clay modeling. The third goal of this solution is also to help the design studios to collaborate more efficiently with the rest of the organization, especially the engineering department. As you know, products in the consumer markets in many industries are becoming more and more complex, especially with smart products, where designers have to embed a lot of engineering constraints, system constraints, and electronic constraints. So we really need to facilitate this collaboration, and this is also something we want to achieve with CATIA for creative designers. And finally, helping the project to be faster by having a better collaboration between the creative designers and engineers, but also to improve the design quality, because this collaboration can also support the participation of every actor on the creative process. And last but not least, as there is a trend in the design studio to address multiple markets in multiple countries and maybe opening design studios everywhere on the planet, we also need to facilitate this co-creation global networking. And this is especially what we want to address with the new architecture of CATIA for creative design. So now let's deep dive on this solution, CATIA for creative designers, around the Silverbull motorbike project, from the ideation to concept modeling and Class A surface refinement and reverse engineering, to the design validation and color and trim studies with the physical prototype and the virtual prototype. So the first step is really to help designers in their ideation phase, still working by sketching by hand or with other sketching virtual tools. But then we are introducing a new technology to help to transform the 2D ID into a 3D reality with the introduction of a technology called Natural Sketch for 3D sketching. The goal is really as an additional tool to your 2D expressive creativity to help you to transform your creativity into the 3D world. So you have three things with this technology. The first one is to express your creativity now directly in 3D, but also to transform quickly and easily your 2D ID into a 3D reality because you're sketching directly in 3D, which will avoid any kind of sketching mistakes and improving the quality of your sketch. And last but not least, as you're sketching in 3D, we can also sketch directly on 3D objects to explore detailed design alternatives or new design directly on 3D objects. We also discover by sketching directly in 3D, this tool is also a very good way and communication tools to help the designers to have a better collaboration with the modelers, because designers can already sketch their design intent on the 3D object that will be reused by the modelers. So it's a very good creative tool, but also a very good communication tool between designers and modelers. So we'll go into a video demonstration, and for that I will give the end to Kamal.
So here we are in CATIA V6. As you can see, we have changed the interface to make it cleaner with very few icons, the only icon you need. And here what you have is having the motor of the motorbike, and you are able to import your 2D sketch because we expect CATIA Natural Sketch to be complementary with 2D sketching, and you are able to manipulate your sketch in your 3D space in order to put it in position and to be able to start your 3D sketching. So now the engine is ready. You can see the 2D sketch, and we will start to sketch in 3D. So in one plane with real-time symmetry, you can see that we are able to duplicate our primitive circle. And as you notice, because we are in 3D, it's already being ellipses as soon as you start to move and to rotate around. Of course, you can set up your perspective. And here is a key element of the design is the arch that is coming from the back to the front of the motorbike. And what we do is combining two curves by sketching one curve on one view and another curve in the other view, and it will automatically create a full 3D curve. So let's do it again in multi-view mode. So on the side view, we start to sketch. Then we sketch again on the top view, and the combination of those two strokes start to do a full 3D curve in the perspective view. So that's how you can create a full 3D curve only by sketching. So let's go a little bit further. That's the kind of sketches you can do at the end of creativity session. So you can see that we already have a good idea of the global proportion of the object. And let's see now how you can create surfaces directly from the sketch. So 3D curves that you have been able to sketch are directly reusable to create your modeling. Here we use CATIA Imagine and Shape with Subdivision surfaces, and we have real-time visualization with car paint that makes this surface also a good starting point to have a validation about the shape itself. And because you are inside CATIA, you keep the link. So if you modify the inputs, so here the curves that help you to create the surface, you see that the surface is moving. Let's see now the third step, how you can communicate with, for instance, a 3D modeler, how you can add detail by directly sketching on the 3D surface. So the software is able to allow you to detect automatically the surface on which you want to sketch, and directly you can sketch on top of it, and you can, of course, put some annotation to explain to, for instance, the 3D modeler that is working with you, where you want, for instance, to add an element, here a grid, exactly in this position. So directly the creative designer can give the inputs to the 3D modeler using CATIA Natural Sketch.
Thank you, Pierre. So the idea of Marc Boulangé was really to underline and to highlight the beauty of the engine. That was the thematic of the Silverbull project. So it was easy for him to use Natural Sketch as a 3D sketching tool to be able to do his design around the 3D engine. That's why he liked to use the Natural Sketch. It's really a creative tool in the ideation phase to really work and express his creativity around the 3D referential, which is the engine. And then he also used the Natural Sketch to start to show some character lines, some sections to the digital modeler. So here it's another example of a motorbike where you can see the complementarity of the 3D modeling, but also the 3D sketching around it, to really in the ideation phase to express your creativity and to communicate with the modeler. Then, as I said, we wanted to make this 3D technology accessible by the creative designers, so we worked a lot on the user experience to make it very simple, accessible, and intuitive. So you saw that on Natural Sketch we have user experience and a user interface which is very similar to the pen and the paper. And for that we are working in collaboration with Wacom by sketching with the digital pen. But now we are also introducing multi-touch user experience, which means that while you're modeling, you can also navigate with the multi-touch experience of the new Wacom 24 HD Touch. So for simple manipulation like just turning around, zooming, and panning around your object and your model, you can use a multi-touch user experience. And then as soon as you need more precision, for example, to sketch by using Natural Sketch, then you can continue to work with the digital pen and have the full precision of the gesture of sketching with a natural way, like you're sketching with a paper and a pen. So here with this Wacom tablet and with CATIA for Creative Designer, you can combine both approaches and both user experience. Multi-touch to navigate in your environment and to manipulate some objects, and digital pen to have more precision while sketching and modeling. So then when the project maturity evolved, then the designer wants also to start to work on the concept modeling stage and also on the creativity, but also by doing virtual clay modeling. So this is where in CATIA for Creative Designer we are offering a new technology called Imagine and Shape based on the Subdivision surface modeling. And what we want to provide with this mathematic is really a new paradigm of modeling like virtual clay modeling, which is very important when you're in the ideation and concept modeling phase, which allows designers and creative people to do quick design exploration and modification, and at the same time it's very easy to use and easy to learn. So very quickly you can access to a technology that allows you to be creative directly in 3D like a virtual clay modeling. So for that I will give again the hand to Pierre Maheu, who will show you how it works on another motorbike.
Thank you, Xavier. So here, for instance, we are in the context of a full motorbike with the full engine, and that's a value of CATIA is being able to design in context. And here we will start to deform our virtual clay. So we start with a sphere, and we are able to change the shape of it by just moving and pulling the global mesh of the surface. You notice that we also have the shadow between the object that is real time. That's what we call ambient occlusion. So here we will start to design this motorbike seat on one side, and we will do the symmetry at the end. So how you use subdivision surfaces is you start by a global volume, and you start to deform it and to add more subdivision where you want to add more detail. So here, for instance, I'm adding 5 new subdivisions, and I will be able to use them to modify the shape of my surface and my object. As you notice, what is an important value for the designer is it's always keeping the continuity of the surface. So you won't create any holes in your surface. Everything going to be continuous and smooth transition. So you are able to move, but you are also able to rotate, to translate your your mesh in order to achieve the shape you want to get at the end. It's very flexible and very efficient. Just imagine the same scenario with a curve-based approach. It will take probably 5 times more time. So here, for instance, we are able to connect to the context of the fuel tank. So we are able to put in the continuity of the fuel tank. Now we will achieve the right shape on the top view. So we start with the side view. Now on the top view, we're able to modify and to follow the context shape. Again, we have the full model of the full motorbike with the engine, with the fuel tank, with the wheels, etc. So we are able to design in the real context.
Hello, apologies for this slight technical hitch. We appear to have lost the sound momentarily, but we're working on it, and hopefully the guys will be back very soon. Thank you.
Okay.
Sorry everyone, I think we've been disconnected from the audio system. I hope everybody is hearing us. If so, we are starting back the conference.
Thank you.
So yeah, we were, yes?
Yes, we can all hear you now, so please carry on.
Okay, sorry for the inconvenience. So let's continue the conversation. So we were talking about how to do concept modeling and ideation with virtual clay modeling with a technology called Imagine and Shape on the seat design of this motorbike. So the concept is to allow designers to be creative also directly in 3D just by playing with the object and the 3D geometry. Just by moving, pushing, pulling the control point, the faces or the edges to finally look and find the final shape that the designer is looking for. So it's a very nice and quick 3D creative tool. So here, for example, we achieve a first level of the overall shape we would like to achieve. We do automatically the symmetry, and then we are starting also now to study the materials in real time. And when you want to have more detail with this mathematics, you just need to subdivide the area where you want to add more details. So for example, here we divided the back of this seat in multiple faces because we want to add an handle on this seat. So then we will take this face and we just do an extraction, and you see automatically the symmetry updating. And you see that it always maintains a G2 continuity between all the faces. And just by connecting two faces, again, it will automatically connect in G2 all the surfaces, all the patches. So it's a very creative tool, an easy to use tool, an easy ideation and concept modeling exploration tool with a pretty high quality of surface at the end. So it's based on a mathematics called the subdivision surfaces, which is very similar to virtual clay modeling. So here we end up to a more precise and final project. And the beauty of this mathematics being integrated within CATIA is that at any time you can use any other tools of CATIA. For example, here we are using a gap feature coming from the CATIA Icem tool that will also work automatically on these subdivision surfaces. And then you can relaunch this command at any time to change the gap on this subdivision surface. And again, being integrated in CATIA means that you can use all the other tools of CATIA, like KnowledgeWare on this example, to generate automatically the stitching on this seat design automatically. And you can use your subdiv surface for any other tools or activities like milling, rapid prototyping, or anything else. So it's an easy to use, very quick design exploration tools directly in 3D with a pretty good real-time visual feedback. So then, when the designers made this ideation with sketching by hand in 2D, but also natural sketching in 3D, and starting to study several concept design with the virtual clay modeling approach, the designer can study multiple design alternatives, and then when he starts to converge to one or two projects, then he can go to another stage of surface refinement with more advanced surface tools to converge the styling constraints with the engineering constraints. Engineering can be legal, manufacturing, engineering, and technical constraints. So for that, we have integrated a technology coming from Icem technology called CATIA Icem to have very high quality, let's say class A surface quality within your creative workflow. So by integrating CATIA Icem, another designer can achieve higher surface quality, which means that they can do explicit modeling or associative feature-based modeling. That's the beauty of combining Icem approach, Icem mathematics with the CATIA power. So it's class A surface modeling with the full precision of Icem and the feature-based associative modeling power of CATIA. Then it's also bring to the CATIA for Creative Designers user a set of specialized function features and diagnostic tools for expert modeling like helix design, gap surface, automatically gap surface generation, accelerate surface, lofting surface, tubing, and so on, but also some advanced analysis tools to check at any time the quality of your design and your surfaces. And then it also integrates bidirectional native interoperability between CATIA and Icem self, made by Dassault Systèmes, who owns the proper intellectual property of the Icem file format. So here is an example on the Silverbull motorbike project made by Marc Boulangé. So at one point of time, he wanted to create a physical prototype of this cup around the motorbike, and so he's working now with CATIA Icem to create the final surfaces, but he wants to have these final surfaces fitting the point clouds coming from the physical prototype. So it's the air intake here, and by working with CATIA Icem integrated, then you can have access to both approaches, which means the explicit approach of Icem self, so playing with the control point or the CVs to fine-tune the overall quality of the surface and to have the full precision and control of the surface, to have the perfect highlights on the surfaces, but at the same time keeping some constraints. For example, here the continuity with the other surfaces. Here I think we are in G2 or G3 continuity with the other surfaces. So that's the beauty of the integration of Icem with CATIA, is that you can continue to work in an explicit mode, manipulating and controlling with high precision all the control points, while maintaining the associativity of the features to the different surfaces. So if we move to another example, for example, the cap of the fuel tank, you see that there is a surface around this cap, which is a special feature of Icem called the accelerated surface. So this is where the designer can play with the surface and the acceleration of the surface to have the very precise highlight and reflection on this face. So for example, here the designers want to change it because it doesn't really like how the highlight is going on. So you can change this feature, this accelerated surface feature, from dialog boxes, but also to manipulate directly on your geometry, and you see that it's always updating automatically all the other geometry, like it's doing automatically the stitching, of the other surface around it. Another example, between the cap and the fuel tank, we are creating automatically a gap feature that will automatically generate the fillet and the flange and doing the stitch around it. And you can play automatically with the value of the size of the gap, and you can see automatically the regeneration of all the geometry. For example, here the designer made a modification, like for example changing the position of the cap, and this is where the feature-based associative approach is very interesting, is that if you move one of the constraints, it's re-updating all the model. You don't need to rebuild all your Class A model. Another example, here on this cap, we want to create some small pockets to have a better grip on the cap. And here we are working with CATIA Icem to have very high, precise definition of the model with features like ball corners, with real-time manipulation of the ball corner, to have high-quality reflections and highlights. And then we will use this object, this small pocket, as a template in CATIA to create all these grips. So for example, here in CATIA, I'm looking for this new pocket now, done with Icem, with CATIA Icem. And I will use a knowledge pattern to put that pocket on the cap, and which will automatically generate all the numbers of pockets with a radial pattern. And it will automatically generate the cutting, the stitching of all the surfaces. And then as it is associative and feature-based, at any time I can change the number of pockets I want from these patterns. Here it is 12, I want 5. And then I can very quickly explore new design alternatives while keeping a Class A surface quality. So I can still have high quality surfaces of G2 or G3 continuity while playing with the power of the associativity. So it's combining the precision of Icem with the power of CATIA. Another example is, for example, I have a logo that was made by another designer with a subdivision surface mathematic, and which is at a totally different size and position. So I will use a shape morphing feature to position this logo on my Icem surfaces. So here I will use this shape mapping feature that will automatically rescale and reposition and map these subdivision surfaces onto the NURBS. And then I was explaining that what we wanted to provide in this solution is a unified modeling environment, which means that we want to give the choice to the user at any time to choose which mathematics he wants to use and to be able to combine them. So for example, here the logo is a subdivision surface and the cap is a surface made with Icem. Then you can create a spanning fillet to connect the subdivision surfaces with the NURBS or the Bezier surfaces. And it's totally associative. So if somebody is changing the logo, it will re-update all the spanning fillets. This is what we call the unified modeling environment. So then Marc Boulangé achieved a pretty high quality surface definition of this model by integrating also all the engineering constraints. Now he wants to take some design decisions with a physical prototype to study the proportion and the volume, but also to make modification on the physical prototype. And by using the CATIA reverse engineering also to go back to the virtual prototype to continue his design, and finally to work in an hybrid world with the physical and virtual mock-up. But then he wants also to do some design validation on the virtual prototype. And this is where we did a lot of improvement in CATIA for Creative Designers to offer both technologies. First of all, a real-time visualization engine that should participate in the creative experience while you're modeling to have a pretty good visual quality, to be able to study the volume, the proportion, and to have a real-time experience of your materials, colors, and every related visual topics. And then if you need more accurate design decision tools, then we introduced 2 years ago a new engine called iRay for interactive rendering, doing interactive Raytracing and global illumination. So with these two engines, real-time visualization experience and interactive rendering, you can address multiple design challenges like design experience creation, but also design presentation, color and trim studies, perceived quality studies, as you're in your 3D modeling environment, working with the fit and flush, gap, tolerances in real time with physically correct visualization. But you can also prepare visuals and CGI for technical and marketing documentation. So let's see in action how it works for the real time, but also the interactive rendering. So for the interactive rendering, as I said, it was based on a technology called iRay from NVIDIA Mental Images, which has the particularity to be able to do interactive rendering, Raytracing, and global illumination with a physically correct engine, and which can take benefits of the power, the computation power of the CPU, but also the GPU through CUDA. And on our side, we integrated this technology with very easy to use and lifelike user experience. So for example, here we are working in real time. We are still in our design experience tool. So this is the visual quality we can have with real time ambient occlusion. But you can also see in real time your environment, your HDRI environment, to see how your object looks like in context. And we deliver libraries of HDRI environment, but you can create and bring your own environment. And then you can start to work on the colors and material by applying materials from your own library or from the PLM library of your company. And just by drag and drop, you can apply materials. So in real time, you can start to work to study the volume, the proportion of your design, but also to start to work on the color and materials with a pretty good level of visual quality. And then if you need to have more precise and more accurate visualization, then you can just activate the interactive rendering mode, which means that now you have all the ray tracing in terms of reflections, shadows, diffractions on the glass, but also the global illumination in terms of lighting and shadows. So for example here, we want to see now in ray tracing and global illumination how the design is perceived in different environments. So again, just by selecting the HDRI environment, you can bring back the lighting source, but also all the reflections of the environments and the reflection of object to object. And with the live rendering, lifelike user experience, that we wanted to be very similar to the camera shooting. You can use the Voodoo interface to work on the perspective, the depth of field, the exposure and the aperture, but you can also work with some tone mappers parameters like the black balance, the white balance, or the vignetting to adjust the final picture that you want to produce. And you notice that we are always in an interactive, iterative work. It's not that we are preparing renders for the end of the week for the board meeting. This is an interactive, creative experience. And again, you're always in CATIA for Creative Designers, so at any time you can change the shape with the subdivision surface or with CATIA Icem and to see how it looks like with this visual quality. There is no data exchange, no data transfer, no data preparation. You just activate this mode of visualization. So it's pretty efficient, pretty quick to combine the modeling creativity but also the visual creativity. And then that's what we introduced in 2013X. It's also to prepare some background rendering. So for example, if you want to prepare some cameras and some shootings for the night or while you're working on the modeling, you can also manage a list of a render queue, which is where you set up the screen resolution, the size resolution of your image, but also all the tone mapper parameters. But also the convergence criteria. If you want to stop the rendering after a number of iterations, or if you have a time constraint, just produce and save the image in 1 hour because I have my meeting in 1 hour, or a criteria of quality. You can say to the software, save the image when the quality is good enough. And then you can see in the render queue all the renderings that you're doing while you're working in your CATIA environment. So you see here some example of the Silverbull motorbike with different colors, different materials, but also different point of view and in different environments. Okay, some examples again of renderings made with this technology, this interactive rendering technology to study the colors, the materials, the volume, the proportions of the objects with different environment, lighting environment, with HDRIs from different kind of products, from cars design, product design, boat design, cars. And here you can see in this image that we also use this engine to visualize the sketching made by Natural Sketch. So the render engine is totally integrated. It works in your modeling environment, which means that you can use it for any kind of geometry. For example, here the sketch, the 3D Natural Sketch, we just applied emissive light shader material on these Natural Sketch sketches. And you see how it looks like with the interactive rendering and global illumination. Other examples in product design industries, like high-tech. Like jewels and diamonds, where you cannot study the design of the product without this level of quality. I mean, the diamonds is behaving in a certain way, and it's participating to the design of the object. So real time is not enough to simulate this kind of behavior in the diamonds. So this is where interactive ray tracing and global illumination is critical. To be able to design such objects, you need to have this level of visual quality. Also for transparent materials like glass, so you need to study the behavior of the glass with ray tracing global illumination. And here's some example of interior design of airplanes, where the global illumination simulation is very important to really understand how the design impacts in terms of ambiances. And as you can play with the lighting, so it's based on HDRI lighting, image-based lighting, but at any time you can add any kind of lights, even physical light definitions. So you can study how the lights coming from the outside of the airplane behave, but also in combination with the lights inside the cabin. And by the way, in this example, in this airplane example, the objects which are designed here are made with different mathematics. For example, the seat is made with subdivision surface. The cup is made with partly with subdivision surfaces and some other parts with the Icem mathematic. So you can use different kind of technologies and mathematics. You can also play with this engine to simulate day and night simulation by putting emissive light on some object and also playing with the intensity of the environment to also work on that. So we covered a complete creative workflow supported by CATIA for Creative Designers around the project of the Silverbull motorbike made by Marc Boulangé, sorry. If you have any further questions, I think we have a Q&A session for the next 15 minutes, and I will give the end to Owen for hosting the Q&A.
Thank you very much. I'm sure everyone will agree that was a really fascinating and inspirational presentation. Before we open up the questions to the other members who've been watching, I wonder if you can briefly explain how you guys became involved in the Silverbull project.
Yeah, sure. So Marc Boulangé is a designer who used to be a student in a design school in France. And I think it was 2 years ago, we did a design contest, CATIA for Creative Designers design contest worldwide. And Marc Boulangé, for this contest, has the idea to bring his dream to reality by using CATIA and to propose the design of the Silverbull to the contest. So it's Marc Boulangé who made it from his side when he was a student. And he was one, by the way, he was one of the 3 winners of the project, of the contest, sorry. So this is how we got in touch with Marc, and we discovered his project of this motorbike. And then we started the collaboration to also continue the work together on the Silverbull but other projects. And now Marc Boulangé is working in a French company called Icem and Design, which is doing concept cars for OEMs with a physical and virtual prototype.
Okay, great. And I mean, it's clear really that that the software kind of really enables the designer to tap into their creativity. Are there any examples that you can give us in the Silverbull bike where the software enabled Marc to really kind of express the ideas that he had?
Yeah, absolutely. In fact, if you understood the theme of his design, Marc Boulangé is a big fan of motorbikes. He loves engines and mechanics. And the theme of his design was really to highlight the beauty of the engine. And that's why, by the way, he participated to the contest and he loves CATIA, is because, you know, CATIA is coming from the engineering world, and he wanted to be able to work directly on the engine, on the precise, exact engine. So his theme was really to highlight the beauty of the engine by sketching directly around the object. This is what we were showing with Natural Sketch, by being able to do a 3D sketching creativity directly around an object. And this is what he really liked, and that really helped him to be creative directly by working around the object that he wanted to highlight the engine itself. So on this aspect, it really helps. And then by using the rendering technology, the live rendering technology, he could also sell his design, especially for the contest. So finally use renderings to present his project to the contest. So he helped him to, CATIA Creative Designer helped him in 2 ways. The first one was to be creative, directly in 3D, but also to sell his design with visualization.
Great, thanks for that. I know that during the presentation, the attendees have been sending over many questions for you, which I believe have been sent to Arnaud. So if we'd like to make a start on going through those, that would be fantastic. Thank you.
You're welcome. So we got some questions from the Citrix WebEx webinar tool. One of the questions is, when using the feature modeling command in CATIA Icem, will the surface still hold the continuity to the surrounding surfaces when they are changed? So this is exactly what we are providing by integrating Icem within CATIA. Is that when you go to this level of precision, let's say class A modeling, you really need to control very precisely the surface. That's why the control point manipulation is very important. But the point is that when you're working like that, if you make a modification on one of the surface, then you have to rebuild all the other surface with the traditional software. With CATIA Icem, what we want to provide is to continue to provide the quality and the precision of modeling of control points, but also to add feature-based associativity, which means that when you manipulate a control point on the surface, the feature is called the feature modeling. When you manipulate the control point, then you are able to manipulate and to change with all the precision the surface by manipulating the control point, while keeping the continuity with all the surrounding surfaces. That's the magic of the integration of Icem within CATIA. So I think this is exactly the question that the person was asking. Yes, you can do it. It maintains the continuity, so you don't have to rebuild all the surfaces when you make a modification on one surface. There is another question. Is there a way to do patterns in Imagine and Shape? Pierre, if you want to answer.
Yeah, so in Imagine and Shape, you're able to create what we call instances. So you're able to do some copy of subdivision, and when you modify the mother subdivision, the children will be updated in the same time. So you could do patterns, and you can keep the associativity in order to be able to update them.
Thank you, Pierre. One more question. A lot of changes in version 6 2013x. Do we get the update of these new tools for the same version? Not sure if I really understood the question, but yes, in the example here we were showing a lot of new things coming with the version 2013x, which has been announced last month and which is available on the market today. But these new features are not available in the previous releases. So it is, some of them are specific to version 6 2013x. For example, the batch rendering in live rendering is specific to 2013x. Okay, I don't see more questions. Gentlemen and ladies, it's your last chance to ask questions. Don't hesitate.
I think we've gone through all the questions now. Thank you guys so much. I mean, that was a really fascinating and very inspirational presentation. I'm sure that everybody watching will agree with that. Please remember also that this webinar is going to be uploaded onto our archives, onto Car Design News, which can be accessed via the Processes tab on the homepage. We've also written an article on Marc Boulangé's Silverbull Bike, which you can also see on Car Design News, and it just gives you a little bit more of an insight into the process, but also into the thought processes behind the concepts. Thank you again, and please don't forget to watch out for the next CDN webinars coming in the new year. So it just for me to say a very happy Christmas to everyone, and we'll see you next year.
Thank you.